Hello and welcome back to IXL tutorials. This is Mr. Duffick and today we're doing IXL E8, which is finding the distance between two parallel lines. So this is very similar to the last IXL E7, except instead of finding the distance between a point and a line, we will be doing it between two lines, two specifically parallel lines. So the questions are going to look very similar. Instead of giving us an equation of a line and then a point, they're going to give us two equations of lines. So first, they give us y equals 1 for our first line, and then y equals 5. So it asks us to find the distance between these two lines. So I'm going to use Desmos for today's IXL just for easy graphing purposes. So I'm going to type in y equals 1, and then I'm going to type in y equals 5, because those were the two lines that it asked for. So here's the first line, here's the second line. What is the distance between these two lines? Okay, well, it's just 1, 2, 3, 4. Just 4, right? So we'll answer 4. Okay. Now understand that you don't necessarily need to draw on a graph every single time. If you can do it in your head, that's perfectly fine, right? How do we get from y equals -1 to y equals 2? So how do we get from -1 to 2? Well, we just go up 3, right? It's just a distance of 3. So type in 3 there. Okay. Same deal here. How do we go from x equals -6 to x equals +1? How do we get from -6 to +1? Well, we move 7. The distance is always going to be 7, no matter where you are on the map. Okay, so you're going to see these are largely the same up until you get to a certain number. I'm going to jump here, and now instead of giving us very basic lines, they're going to give us two slanted lines. So our first line is going to be y equals -x plus 5. So I'm going to type that in right now. Y equals -x plus 5. And then the second line they give us is going to be y equals -x minus 4. So y equals -x minus 4. Okay, and we can see here that the two lines are indeed parallel. Okay. And then just like the last set of problems, now we're going to have to do a little bit of work involving the distance formula to get our answer. So we'll go back to the question here. We'll do this. Grab this. Okay. And so the first thing I'm going to write down is the distance formula. I'll just write it right here. We have d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we're going to focus on our two equations. Equation 1 is right here. Equation 2 is right here. And now we're going to compare this equation with our perpendicular line. And let me show you what I mean by that. If you remember from the last set of IXLs, you will remember that what we did is we made kind of a perpendicular line between our point and our line. So in this case, instead of going through a point and a line, because we don't have a point, we're going to make a perpendicular line that goes through both lines. So it's going to be perpendicular to both set of lines. And what you want to do is you want to choose a perpendicular line that will go through one of the lines where they intersect on the y-axis. So right here, this line intersects at the y-axis on 5. And so we're going to draw a line. It doesn't really matter. We'll do y equals x and then plus 5, something like that. So we're going to draw a perpendicular line just like this. You can ignore this specific formula. Just understand we wanted to draw a perpendicular line that would go through both lines, and also that went through a point on the y-axis, or the y-axis, the y-intercept of the other line. So we're going to pull this point right here, which is 0.5. We're going to go back to our Desmo, or to our pad. Okay, so we're going to compare this equation with our point of 0, 5. Okay. Now, when writing our new equation, remember we want to find y equals mx plus b. Okay. And how we're going to maneuver through this is our m is going to be the opposite reciprocal of the slope of our first equation, right? Just like with our other set of IXLs, since our second line, the second equation we're going to come up with is going to be perpendicular to our first line, that means the slope is going to be opposite reciprocal. So we have y equals the opposite reciprocal of -1, right? It's always a number right before x, so -1 is just going to be +1. So 1x plus b. All right, and now we have our point here, and we're going to plug that in to our y and x. So we'll do 5 equals 1 times 0, which is 0 plus b. So we're just left with 5 equals b. And so the equation of our second line is going to be, or of our perpendicular line is going to be y equals x plus 5. Okay, that's going to be the equation of our second line, just like that. Because we have y equals x plus 5 and we have y equals -x minus 4 over here, we're just going to set them equal to each other, right? Since y equals this and y equals that, we can just set the x plus 5 and the -x minus 4 equal to each other. So we'll do that right now. We'll go x plus 5 equals -x minus 4. And so I'm going to add x to both sides, kind of like that. We have 2x plus 5 equals -4. Then we're going to subtract the 5 both sides. We're left with 2x equals -9. So x is going to equal -9/2 or -4.5. You want to divide that out. Okay, so that's what the x coordinate is going to be of our point for the second line. And then we're just going to plug this back into the original equation to figure out what our y is. So y equals, our x is negative minus 4.5 minus 4. So I just plugged that negative 4.5 up into our original second equation. And that's going to simplify to 4.5 minus 4, which equals 0.5. So y is going to equal 0.5. So the second point that we are going to plug into our distance formula is going to be -4.5, comma 0.5. Okay, we're going to hold on to this. Now we're going to go back and we're going to do the same process for our first equation. We kind of skipped over it after we found our equation of the perpendicular line. So now we're going to set this equal to our original equation. So we're going to go -x plus 5, right? Just that part of the equation equals x plus 5, which is the part of the second equation, the perpendicular equation. And so we'll add x to both sides. So we're left with 5 equals 2x plus 5. Then we will subtract 5 from both sides. So we're left with 0 equals x. Okay, well, that makes that easy. And then we're going to plug our 0 back into the original equation. So y equals 0 plus 5, or just 5. So y is going to equal 5. Meaning our first point is going to be 0, 5. Okay, so we have our first point we're going to plug into the distance formula, and we have our second point we're going to plug into the distance formula. So now let's do it. So we'll have the square root of, and I'll do point 1 as my x1 comma y1, and I'll do point 2 as x2 comma y2. So parentheses, x2 is going to be 0.5, I'm sorry, negative 4.5, and then minus 0, squared plus y2 is going to be 0.5 minus 5 all squared. Okay, that's going to equal minus 4.5 minus 0 squared. So 4.5 squared is going to be, and I might have mentioned this earlier, but what's cool about these kinds of problems is even if you end up with a negative number like negative 4.5, the number is always going to be squared in the end. So it's always going to end up positive. So it doesn't matter if you do 4.5 squared or negative 4.5 squared. So I'm just going to type in 4.5 squared. Or 4.5 times 4.5. And that's going to equal 20.25 plus minus 5, or 0.5 minus 5 is going to be negative 4.5. So just like our other part, so we know this part is going to be 20.25 as well. Okay, so when we add those two together, that's just going to be the square root of 40.5. And so when we do the square root of 40.5, that is going to equal 6.36. Now, the problem wants us to just do the 10th place, which is just that first digit after the decimal. So that's going to be 6.4. So our distance is going to be 6.4. 6.4. And that is going to be correct. So I'll stop here, and I'll catch you for the next IXL tutorial video later. Take care and goodbye.